Good afternoon. Welcome to One Spatial Australia's free webinar program, where today we will be talking about lightening your load with Fme Server. And today we have a number of people that will be presenting, but we'll just play a short little video to give you a bit of an introduction to One Spatial and what we offer, and allow a bit of time for people who are taking a bit of time to hook on. So I will now play the video. Sit back, relax, and enjoy the next 2 minutes. Just a bit of an introduction to the One Spatial Australia team. We have Andrew Bashfield, who is our sales manager, Simon Laird, our services lead, Emma Yates, marketing manager, Tom Farrington, senior consultant and manages our training program, Daniela White, a sales, Priyantha Palagama, senior consultant and manages our support team, Sam McDonald, senior consultant, Michael Studdard, a sales consultant, Assis Mananda Ha, senior consultant, and myself, Andre Makika. I am the country manager for One Spatial. On behalf of the team, we welcome you and hope that you will enjoy the next hour. We do have very special presenters that are with us today. Don Murray, the co-founder and president of Safe Software, and Holly Coxon, Fme Server Technology Expert Team Leader, who will be presenting on dynamic engines. Just a little bit about One Spatial. One Spatial has been around for 50 years providing geospatial solutions to the spatial industry. We are an organization or a company that specializes in providing solutions. We have offices all over the world, with head office being in Cambridge. We have offices in Ireland, Belgium, France, Tunisia, US, and in Australia, where we have 2 offices. Our head office is in Sydney, and we also have an office in Melbourne. We partner with a number of technology partners, and of particular interest and note is that we are the platinum distribution partner for Safe Software, and we provide Fme product support, training, and consultancy services. We work in a number of industries, such as military, telecommunications, government, transport, emergency services, and so on. We are a software solutions provider, a global expert in managing location and geospatial data. We strive to make the world safer, smarter, and more sustainable for our futures. We help customers to unlock the value of their data to create a smarter world and deliver powerful data solutions and applications on-premise, mobile, and in the cloud. We are a customer-centric business. We do deliver solutions to address our customers' needs and market requirements. And above all, we pride ourselves on being collaborative with the people that we deal with. We have a number of solutions that we offer with our One Spatial management suite, and we also provide Fme integration platform where we provide Fme desktop, server, and cloud. And if you want more information about that, please get in contact with us. I'd like to take this opportunity to highlight that at last week's partner conference, electronic or virtual conference, One Spatial was awarded the Partner Award of Excellence for Global Alliance, continuing recognition of the level of support for our Fme customers around the world. And on behalf of the team at One Spatial, I'd like to thank SAFE very much for that recognition. What we'll be covering today, we'll be covering enterprise integration, which will be talked about by Sam McDonald, creating APIs, who will be presented by Priyantha Palagama, or Pri to his friends. Dynamic engines from Don Murray and Holly Coxon. We look forward to that. Dashboarding made easy from Assis Manandahar. And at the end, we will have our Q&A session. And on that note, I'd like to welcome Sam McDonald, Senior Consultant, who will be talking about enterprise integration. Over to you, Sam.
So thanks, Andre. As mentioned, my name is Sam McDonald, and I am one of the senior consultants currently working at One Spatial. And today, I would like to talk to you all about enterprise integration with Fme Server, and probably tell you some terrible jokes along the way, because that's just my style. So I think a good way to start this talk is to ask the question, what is enterprise integration? I fully expect it to be a term that most people have come across, but appreciating just how much of a broad spectrum concept it is a different matter. Enterprise integration is effectively the practice of integrating different systems and environments to communicate with each other, in the name, I guess, but typically this is through the use of middleware. The target of such a practice is to enable efficient data flows and notifications between systems and consolidate the data between these environments, which may not be done efficiently previously. You may have what's referred to as data silos or data stores, or there's about a million names for basically standalone containers of data that aren't communicating and sitting there gathering theoretical dust. Ultimately, providing more reliability and redundancy between these systems is one of the goals of enterprise integration, whilst improving the process of sharing data between them. Now, long gone, are the days, or long gone should be the days, where we would be emailing an update from one department's database to another, and I'm sure there's some more horrendous stories about how we pass data along, and more specifically the flaws that come with these processes. This talk is going to take a look at the idea of Fme Server as a middleware communicating between systems and transforming data as required, because let's face it, it's pretty good at it. So firstly, let's talk about invoking workplaces workflows in Fme Server, a topic that really triggers me. Yes, the jokes are coming, they're terrible. Fme Server has plenty of options when it comes to receiving messages to invoke work streams. And these options include Amazon S3 buckets being modified, Amazon topics being notified, Amazon SQS messages received, Azure event grid events received, directories modified, Dropbox directories modified, emails received, IMAP and SMTP. Fme Server topics notified, so that's the internal notifications for Fme Server. An FTP directory being modified, JMS messages received, that's a really good one to talk about. Schedules initiated, again, that's an internal scheduling system for Fme Server. System events received, which is internal to Fme Server. UDP messages received, WebSockets messages being received, and webhooks being triggered. There's a few options there. I don't have the time to talk about all of them. I'm sure I could if I wanted to consume everyone else's time, but I do have time to talk about some of them. And what I want to start with is webhooks, also known as, you might have heard them referred to as reverse APIs. Webhooks, they provide an excellent way of subscribing to certain events to enrich the incoming content into Fme servers, an Fme server workflow. Data is received via a HTTP post call from some external system. Typically, when there is a change in state and or a change in data, this is the key element of it, because webhooks have the advantage of being far simpler and resource efficient than using API calls to constantly poll a location and ask it, has the data changed? Has the data changed? No, okay, I'll ask you again later. And a lot of providers don't particularly appreciate that. I know the example that we're using later on, which is GitHub, does not appreciate it at all. Do not constantly poll their API. And the other fortunate thing about webhooks is that they're extremely easy to set up in Fme Server, and in a number of different ways as well. You are capable of simply just dropping a webhook trigger in an automation, and once you save that automation, a link will be provided for you. Alternatively, with the internal notification topics, these all can have post URLs generated for them as well for webhooks. All you have to do is generate that token for them, and then yeah, you're good to go. I think the only caveat really to webhooks, and it's not even necessarily a statement about webhooks, is that there is this potential to need to make your server instance publicly available in a lot of cases, and can sometimes be tricky, or it could just be that it's tricky for me and I struggle with it. Moving on. So the second one is messaging. This is a topic I really want to talk about, is messaging and message brokers. Message brokers are becoming an ever increasingly popular choice for inter-system messaging and notification, basically just notification middleware in general. They offer a versatility that really is great for modern integration, with point-to-point messaging, which is from queues, from implementing queues, where one publisher provides a message to specifically one subscriber, and one-to-many messaging from topics, where a single publisher can notify any number of subscribers. And this also comes with lots of options around relating to persistence of messages and static or dynamic naming conventions for queues and topics. There's very good reasons why things like Red Hat AMQ, RabbitMQ, that one in the middle right is Apache MQ, and WebSphere are all quite popular because they offer this versatility. And fortunately, Fme Server does support the JMS API out of the box, being shipped with ActiveMQ and WebSphere, which is great. And additionally, and was really good, is that it's quite extensible. So if you run into situations where it doesn't natively support a protocol, it can be extended into it. And so it's extensible into popular protocols such as AMQP and MQTT. I think these are the big two that I think Safe probably hears about the most, and I've probably been exposed to the most. And this is done basically, you can just import the initial libraries that you need and configure the JNDI properties. And I thought I'd just give a quick example of this, because it can be a little tricky at first, but once you know how to do it, it's very straightforward. And this example here was just how I've actually configured Fme Server to communicate on an AMQP protocol specifically. This was as per a client request. And this is just simply accomplished by sourcing a later version of the ActiveMQ libraries. And once you know how to configure the provider type, which is well documented by Apache, which is convenient, the process is fairly straightforward. You just set additional queues and topics in that JNDI properties file, and you're good to go. If I wanted to create even more lots of data, even more lots of data. I just need to add additional entries. And the reason I'm sort of showing this is that I was a bit afraid at first when I started tackling messaging because I was fairly new to the concept and I was doing it in FME. And admittedly, FME, in hindsight, FME helped the process. I think you should not be afraid of message protocols in FME Server. If it doesn't do it out of the box, it can be adapted. And I'm fairly sure SAFe has their eyes on additional protocols in future releases. So looking forward to it. Finally, the directory watcher. I've had a lot of fun and experience with this one. Best thing about directory watching, it's a very simple trigger to set up with a very simple concept. I'm going to peek into a folder location and I'm going to check if a file has changed. Very straightforward. Now, in my experience, the directory watcher is really a great option for triggering workflows in response to files being made available because they're dropped and they're ready to go. But at the same time, the trade-off is it does require some forethought. It is ideal that you, in my opinion, only select the events that you require, the options being create events, modify events, or delete events, to reduce what I'm going to refer to as the noise of that folder. There's no guarantee that you need to know everything that's going on. And honestly, if you're triggering processes unnecessarily, well, that's just a sink on resources. It's inefficient, so you should avoid it. Additionally, if necessary, I am a fan of having what I'll call a pre-processing logic stage in place to filter out unwanted files before anything is actually parsed and read into memory. If you know you don't need a file, why actually feed it into a reader? Just stop the process before you ever read it in. Again, it's an efficiency concern. And additionally, talking about pre-processing stages, you can also, if you want to be organized, you can actually force downstream processes to actually wait until you've received all the files. If you require batch process, you might need to hold up an interface until you've received 85 files and then kick it off with all 85. Finally, it's also worth mentioning with the directory watch that you need to be a bit clever and careful when it comes to large files that maintain an active file stream for a while. So while they're writing for a long period of time, you might end up with a situation where the directory watch, which works on a poll, you set the time that you want it to, on an interval that you want it to check the directory, you might find that it detects a change on a file that's still being written, and then you try and read in a file that's still being written, which is not particularly ideal. In my experience, a good way to get around this is to organize temporary extensions to be written to these files as they're being written, and then remove temporary extensions and have their real extension at the end of it. If you've got a known extension that you can monitor and ignore, that makes life really easy. So those are the triggers I'm going to talk about. Like I said, there's a lot of them, but I don't have enough time to talk about all of them. So we'll move on to the main topic now, which is automations. And this is where Fme Server really starts to shine. Automations are Fme Server's approach to enterprise integration patterns, which are repeatable solutions effectively they're repeatable solutions to address commonly occurring problems related to integrating systems. Basically, they're an approach to connecting A to B, to grossly simplify it. With Fme Server automations, you can easily design your own JSON messaging workflows, which are comprised of three primary components. Triggers, which I've just spent a bit talking about, which fundamentally listen for and receive messages from external clients or from within Fme Server. So this comes back down to the notification topics, these internal ones. Triggers are not specifically external. Then we have external actions, which will send a message to an external client or inside Fme Server. Again, just because external is in the name doesn't mean it's explicitly external. So external actions, effectively the inverse of triggers. And then we have actions. And actions process messages between triggers and external actions, either in an Fme workspace or through another tool. the reality is that the biggest use of actions that you will find is that this is where you run your Fme workbenches in line in your process, as you can see in this right-hand image, which is the demo that I'll actually be going through later. But there are 3 workbenches that are in line there. One that triggers in response to a webhook. The second one, the regression tester, which triggers once the update detect passes. And the third one, which uses the automation writer, which I will get to, also triggers on a successful pass. So these JSON message workflows, how do we manipulate them? How do we manipulate the JSON message? You know, I showed my wife this picture before the presentation. She was a bit put off by it. So hopefully it doesn't scare, it doesn't freak out anyone else. Just this notion of we're puppeteering and controlling our JSON workflow. So there are some key considerations here, and part of the process is really trying to understand what Fme provides as part of this JSON workflow. So one of the first things that you can do as someone who's getting into automations, getting started with it, is observing what key value pairs are available for each trigger. This is very simple because whenever you open up a new transformer, a new external action, you'll actually have a series of variables that are available to you, and these are the parsed values from these transformers. Additionally, you can just dump the entire event JSON, this JSON message, into a workbench and flatten it and get absolutely everything. You can also inject your own values to keep the information rolling. So just as much as you can read in, you can write out key value pairs, specific custom key value pairs that you need to make use of. Now, the really great thing in 2020 is that we got this beautiful thing called the automation writer, which provides a really streamlined approach to this. This is basically a writer that writes directly out to the automation, and it's brilliant, and I love it. If you're not working in 2020, don't worry, you can still inject information, append information into the into your message. Historically, I've done it with notification topics, as you can just, if you pass a JSON to a notification topic, it will append the key values into the existing one. And another thing for really manipulating and controlling your workflow is being able to now define custom outputs and paths. Again, with the automation writer, because the automation writer is the best thing. And this provides a lot of versatility. You saw this on the previous slide that we've just got 2 outputs here instead, 2 additional outputs instead of just these 2. These are a product of the automation writer. Finally, let's talk about looping automations, a really great and dangerous topic. I think the big thing with looping is don't get stuck. It really is, looping's, it's a great way to introduce redundancy in your workflows. When you design these things, when you get them flowing, you may, off the bat, may not have a lot of redundancy. When a workbench fails, it terminates and it just stops the process. And looping is a really great way to counteract that, but a lot of care must be taken to ensure that processes don't get stuck in endless loops. It's really easy to do it. To start the automation looping, all you need to do is enable it. It'll give you a warning, as it should, and then you're on your own and don't get stuck. So the looping is natively supported in 2020 Fme Server once it's enabled, as I mentioned, after you agree to said warning. But it's also actually achievable in previous versions, again with topic notification, that you can pass to a topic and then back to the input of a block. As a generalization, my approach to trying to reduce the risk of infinite loops is that I implement counters that count up to a max attempt and then terminate the process and delay reattempts. These are really good for managing your loops. What I've got on the right, I am not okay with this. I would be upset if I saw it. That feels very uncontrolled. Yeah, I think that's about all I need to say on it. Please don't loop it like it is on the right. And finally, the third part of automation, external actions. This is when Fme starts to get a bit bossy with other systems. So for this topic, I'm just going to go excuse me, I'm just going to go through what's available, because again, there are plenty of options. There are some I make extremely common use of. The big one being making HTTP requests. That's one that I make more use of than anything. You're able to notify Amazon topics, notify Azure event grid topics, notify internal topics in FME, send JMS messages. Sending and receiving JMS messages, the configuration's effectively the same as far as the JNDI properties, there it is. Sending a message to a WebSocket channel, sending a message to Amazon queues, sending emails, uploading to Amazon S3, uploading to Dropbox, and uploading to FTP and SFTP servers. There are plenty of options there as well, but I'm actually not going to go through specific examples on these ones. I'm going to move on to an example pattern that I wanted to demonstrate. And this pattern is something I've actually put together just recently for this talk in response to something that's been on my mind for a while with regard to FME, and that is automating by regression testing, especially in response to when I make an update to a repo and it automatically triggering a regression test.
Okay, thank you, Sam. Pri will now be presenting on creating APIs. Can everyone see my screen now?
Yeah, we can see.
Yep.
I think.
Okay. Thank you very much, Pri. If you would like to present, and I'll give you control.
Thank you, Andre. Good morning, everybody. So my topic is creating APIs. Since this is alone a big topic, actually, so within next few slides, I'll explain basics of building API with FME and provide links to resource. Most importantly, provide links to resources where you can download samples and more information. So API is a set of definitions and protocols for building and integrating application software. API is helpful for interfacing your core business process and data, and to decouple your data and business logic from your public interface. Let's move on. So the next second slide. So as you can see in this slide, the API sits between the user or applications and backend program or the databases. It has a protocol, which is in this case is HTTP, and requests to interact with other resources such as backend databases and programs, etc. Therefore, API should be able to pass requests and responses correctly and report meaningful error messages when something goes wrong. In that case, we can use Fme to build workspaces to implement requests and meaningful error messages. Then workspaces can be published into Fme Server or Fme Cloud to build complete API. With the development of cloud technologies, serverless architecture became popular for developing IT solutions due to its inherent nature of low implementation and running cost, as well as high scalability. It is easy to use serverless approach for building APIs. Cloud-based tools such as AWS API Gateway or Azure API Management provide simple, user-friendly interfaces to build serverless and codeless RESTful interfaces. Then it is easy to implement backend process with Fme Cloud and build communication between them through AWS Lambda or Azure Functions. This is an example of serverless API we have implemented within 1Spatial. To give a background, 1Spatial conducts on-site and online Fme desktop and Fme server training. During each training, for each trainee, we provide access to virtual machine with licensed Fme software, training materials, and other required third-party software. Those VMs are AWS EC2 instances running on AWS Cloud. Each instance costs hourly basis. Therefore, we should make sure to launch instance just before training and terminate them just after the training. Our requirement was to automate this process so we don't get any surprises on our AWS bill at the end of the month. To achieve this, we have created 2 Fme workspaces and published into Fme Cloud. First workspace received list of trainees, starting date and type of training as as basic training runs for 2 days and advanced training runs for 3 days. Then it launches EC2 instances as required and create RDP files for remote access, and then bundle those RDP files into zip file and stream back to the user, who made the request actually in this case. Also, the same workspace store details of the training and instances on a text file. Right, it's moved up. We go job. All right, finally it worked. So also the same workspace store details of training and instances on text file and schedule task on Fme Cloud to run the second workspace to terminate instances at the end of the training. So it's create a scheduled task on Fme Cloud. So therefore we don't need to worry about terminating those instances manually. So Fme Workspace use Lambda functions to launch and terminate instances. And we have built a static web page which is hosted in AWS S3 to enter informations of training and list of trainees. All these components are linked through AWS API gateway through simple HTTP calls. So the Fme server and the front end, the web page communicate through the AWS gateway. Even the Fme server, when it needs to run Lambda function, it uses this API to execute those tasks. So the no server has been used for web hosting, API, and backend process or storing data all on cloud. If you need more information on building serverless APIs with Fme Cloud, please follow the link below for 53 minutes long webinar. It provides step-by-step guide and a sample script to download. So that's all for today. So I hope you got some basics of building serverless APIs. Feel free to forward your questions on this regard to our regular support channel, support@1spatial.com. Thank you.
Thank you very much, Pri. I'd like to now welcome our special guests, Don and Holly, who will now be talking about dynamic engines. So I welcome you if you want to put your screens on and say hello.
Hi there.
Thanks, Andre. While we're just saying hello, would you just be able to make me presenter?
I am now going to make you a presenter.
Perfect. Thank you.
There you go. You should now be presenter.
Great. Okay.
Great. Okay, yes, we thought we'd just turn our cameras on and say hello to everybody since we're just joining you for this afternoon's session.
Yeah.
So yeah, my name is Holly and I'm one of the Fme Server experts at SAFE.
And I'm Don and I'm one of the founders, and yeah, we're really looking forward to this opportunity. So thanks to our good partners, 1Spatial. So yeah.
Yeah, absolutely.
Okay, so with that, I'll turn off. Yeah, so we're going to talk a little bit about dynamic engines in Fme Server. Once upon a time with Fme Server, what it could do is run schedules. And the great thing about schedules was that as people who own server, you could control when jobs were done and you could control the load on Fme Server. But as we've seen today, now we've made the Fme Server itself dynamic. It can react to actions that other systems take through enterprise integration, or take action when other external things happen, like when files are dropped into a directory. And so what this means is that now the Fme Server load is out of the hands of the administrator, and so now it can vary greatly depending on what it's asked to do. And there's also something called Fme Server Apps, and those are web apps that are run on Fme Server. And as we all know, all these things, the users are very impatient. So now Fme Server has to have this ability to handle these peaky loads. And so dynamic engines, so next slide there, yeah. They provide us a new pricing model. So traditionally with Fme Server, you bought a specific amount of processing capability that came in units called engines. And essentially an engine could run one workspace at a time. Many workspaces don't take very long, so you could really do a lot of them. But the point is that it defined the amount of parallelism that could go on in the server. With dynamic engines now, you no longer buy engines, you buy engine time. And so to do this, we've introduced a new pricing model and new technology to track the amount of work that's done. Yeah. So in particular, now what you can do with Fme Server is you could launch a bunch of engines waiting for work even. And the point is that you'd only pay for them when they're actually running, doing work. And it's only CPU time you pay for. You don't actually pay for runtime. So if you had an Fme engine that was spending a lot of time talking to a particularly REST endpoint, API endpoint, web service, you might find that the CPU time is a lot less than the runtime. And so by analyzing your workflows, then you're able to decide when you want to use standard engines or when you want to use these dynamic engines. And if you have a very bursty workflow, like often you will have when you start looking at messaging through things like RabbitMQ and others, these dynamic engines really start to make great sense. Also in these scalable environments, now as we move to the cloud, you're going to see a blog go out tomorrow where we're running Fme Server on Amazon AWS Fargate on EKS. That's a mouthful, but essentially it's a totally serverless Kubernetes deployment, and where you can ramp engines up and down to meet the need. The idea is you only want to have the capacity to do the work when the work arrives. You don't want to have any extra capacity ever. And so dynamic engines really is great for that. There's also organizations that they have systems set up purely for emergencies. And the thing about emergencies is you don't know when they're going to happen. And so you have to have all this capacity on hand. So when the emergency, wildfires in Australia or in BC where we're from, floods, things like that, then you have the capacity there to meet the needs of the emergency, but have it just on standby, and you're not paying for it when you're waiting or you're just in the the being prepared state. So yeah.
Okay, yeah, so other than bursty workloads and scalable deployments, so especially with emergency response scenarios, you want to be able to quickly scale your Fme server to handle those. But there are all sorts of other scenarios that you may run into in which you find dynamic engines are useful for your Fme server deployment. So one of those is if you may have a one-time, infrequent, a big data shift. So in moving a large volume of data, this is going to be exceeding your day-to-day capacity of probably what your Fme server can handle at the moment. So by introducing dynamic engines, this means that you can perform more parallel processing at once, but that you don't need to actually purchase these additional engines permanently on your license. So you can just pay for the CPU time on the engines that you're using for this one-off large shift in data. Other than that, Don mentioned the introduction of server apps. So these were new in Fme Server 2019, I believe. And really, these are designed to allow you to provide a method of self-serve. So this might be an end user within your organization or a customer of yours. And what they're able to do is actually access, essentially it's the run workspace page of Fme Server to simply run a single job. So what this means is they can upload files for processing or download files from your Fme server as well. But if you're going to be presenting this to someone other than yourself, the author of that workspace, you need to ensure that they're having short wait times. So they're not waiting for this data to get processed. So being able to add these dynamic engines that can be assigned specifically to a single server app is really going to help reduce those wait times for the end user. And the other scenario that I wanted to mention was to be able to connect for processing IoT and streaming data. So Sam mentioned a couple of the connectors that we have earlier, but we have a huge range of connectors. And when you are connecting to a webhook, a WebSocket, or any of these streaming services, the jobs processing that data need to be running continuously. They need to be continuously switched on to be able to receive that incoming data. But a lot of that time, they are just going to be waiting, and they're not going to be processing data. And so they're occupying an engine for the whole time, which means it isn't available to run other jobs. So this is another scenario that's perfect for dynamic engines, because you're only paying for that CPU time. So even though the dynamic engine is occupied 24/7, you're actually only paying for that very little processing time when the data is received to the system. And then other than that, Don also mentioned, of course, those bursty workflows and being able to scale up these environments as well. So now on FME Server, we have two different engine types. We have our standard engines, which are the engines that have already or always existed on your FME server. And as of 2020.0, we also have these dynamic engines. So technically, under the hood, these engines perform exactly the same way. But because of these different pricing models, you can start to use these for different workloads within your FME server system. So our standard engines are fixed to your FME server, and so they're ideal really for customers with these predictable and consistent workloads. So as Don mentioned, those schedules that you know are going to be running on a repeated interval, standard engines are great there. But then we have our dynamic engines, which are sold by the CPU hour. So these are ideal for those unpredictable workloads, the streaming and these scalable deployments, these examples that I just mentioned. And so in combination, these can be used together to provide the ultimate flexibility in your FME server. So at this point, I'm just going to step out of my presentation here, if I can do that, and jump into FME Server and show you a quick demo. So hopefully everyone can now see my FME server. And for this demo, I'm going to be using 2020.2, which is our latest official release. But dynamic engines have been available as of 2020.0. So the processes that I'm showing you in this demonstration, you'll be able to do on your own FME server if you're using 2020.0 or newer. So in this demo, I'd like to simulate a unpredictable peak in workload. And so in order to create this simulation, I'm going to be using an automation. In this automation, I have a schedule. And in this case, I just have a schedule because it has a manual trigger action. So I can trigger these workflows to run in real time right now. And then I have a series of different actions. So as Sam mentioned, these are these internal actions that are used primarily to be running workspaces. And that's what I'm doing in this automation here. So I have a series of 3 different workspaces. The first one is simply going to be processing the state of California, and it's going to be breaking it down into the different counties. And all of these counties are being passed out into an automation writer, which is then going to be used to trigger a second workspace, which is going to break down these counties into blocks. This is just an overlay of a grid to break these down for even further processing. And so by doing this workspace, I'm submitting, I believe it's around 960 different jobs. So it's just great for simulating this unexpected increase in workload. And so what I want to do here is basically assign dynamic engines to help take on these jobs and help process them. So let's go over to the licensing and engine page and just take a look at how our dynamic engines look within the interface here. So on the licensing page, the first thing that we can see is we have a section for our dynamic engines. And what you're going to be able to see in this view that's important is how many credits you have left. So how much CPU time you have available on your dynamic engines. So at the moment, I'm using a trial license. And in all of our trial licenses, we include 100 hours of dynamic engines for you to be able to test these new engines out for yourself. So based on the processing that I've done on this machine, you can see that I've already used up a little bit of time here on these engines. So then if I go over to my engines page, you'll actually be able to see the breakdown of all of the different engines that I have available on my system. So on this license, I have 2 standard engines available, and at the moment, I have 5 dynamic engines. But because dynamic engines aren't tied to a license, I can actually launch as many of these as I want here. So I could launch 10 engines, I could reduce this down to 2 engines. So it all depends on what you actually want to be using these dynamic engines for. The only thing that you need to make sure is that your machine actually has the technical specifications to handle all of these engines if they were running in one go. So at the moment, I'm not going to change this. I'm going to leave it at my 5 dynamic engines. And then what I would like to do is I'm managing these engines using job queues. So for each of my automations, I'm processing the counties and then the blocks. And what I have got is 2 separate queues that have been assigned to those run workspace actions within the automation. So whenever any county jobs are submitted, they're going to be sent into my county queue. And the same with all the block workspaces. And then I have a 3rd queue here, which is going to be my holding queue for all my dynamic engines. So at the moment, my county and my block queue don't have any engines assigned to them. And this is simply for demonstration purposes. But in reality, you'd probably have a standard engine assigned to each of these. And then you just wanted to assign dynamic engines once it's going above a certain threshold. But just for the demo, to ensure that we're hitting this threshold, these have no engines on at the moment. And what we're going to see is when I trigger my automation to simulate that peak workload, we're actually going to see the dynamic engines be reassigned to the county and the block queues to help take on this load. And then once the job processing has completed, they'll be returned to the holding queue. And so this means that we're not going to be using the dynamic engines to process any jobs unnecessarily. We only want to be using them for certain scenarios. So how do we actually move these dynamic engines from one queue to another? We're doing that using a second automation. And this automation is, again, running on a schedule. This time it's running very frequently because our workspace is going to be using a series of REST API endpoints to actually check the county and block queues. And so what we have here is a series of published parameters. And the one that's important is our high watermark. So this is a threshold value that can be defined by the user. And what we're saying is if our county or block queues have more than 3 jobs waiting to be run, we want to assign our dynamic engines to those queues to help take on the load. And we also have our low watermark. So once the queue returns to 0, we can then remove the dynamic engines off of those queues and back over to that holding queue. So because this workspace is checking these endpoint metrics, we've set it on a schedule for this example every 7 seconds, just so that it's able to constantly do that and react in near real time to those queuing jobs. So what I'm going to do now is we're actually going to start this automation, and then we're going to kickstart this peak workload and jump over to the engines page to see this in action. So I'm going to start this automation and then trigger our schedule here. And immediately, if we now jump over to our jobs queue, we'll see that all of our county jobs are starting to get queued up. And that's because we didn't have any engines on that queue. So now if we go over to the engines page, in just a moment, we'll actually see our dynamic engines move over to help take on the load of the county, and then eventually move over to the block queue as well. And I always have to have a little bit of patience at this point. It always feels like longer when you're doing it live than when you're testing yourself. Okay, there we go. So now what we can see here is that the counties, so these lines here are the queues that are assigned to those engines. And then as soon as all the counties were processed, the queue immediately got removed from the dynamic engines and they got pushed over to the block queue here. So at the moment, we can see that all of our block queues are running. And it looks like we lost a couple of our dynamic engines there. So I'm not sure. Okay, they just got restarted. So our engines do restart automatically after a certain period of jobs have been run. But at the moment, once we see that there are no other jobs being run on these engines, we'll see the block queue is removed as well, and we'll return to the state that we were in originally. So now all of our dynamic engines are back in our holding queue, and our block and county queues are back to having no engines on them at all. So this was just a simple example of how you can start to use job queues to determine when you want to make use of your dynamic engines. So for example, in the case of a server app, you might have another job queue with the repository that that server app belongs to and a single dynamic engine assigned to it. So the automatic reassignment workflow is just one example for handling these unpredictable peaks in workload. So that's it for the demo. Obviously, there were lots of moving parts there. So I did just want to mention a few different resources, which I think will help you get started and familiarize yourself with these dynamic engines. So we have a great frequently asked questions article, and then we also have a blog post, and the demo that I just showed you is available on the Fme Hub. And it's all the items, so the automations and the queues are stored in a project. So if you're able to get a trial of Fme Server, you should be able to just upload that project and you're good to go. You can try out this example for yourselves as well. So I think that's it from Don and I. So obviously, as I just mentioned, 100 hours is included on the trial license, and that's for 2020.1 and newer. Don, I'm not sure if you have anything else you wanted to add. If not, I'll pass back to Andre.
No, that was great, Holly. Really good. Yeah, exciting. So you can see the power of dynamic engines and how they're able to, relieve when your Fme server gets stressed or be there to handle peak load. So that was really good.
Thank you, Don and Holly.
Okay, thank you. Thank you, Andre. I'm Asis, and I'm a senior consultant here at 1Spatial. And today I'd like to talk about how Fme and Fme Server can make your dashboarding works easier. So beginning. So I'd like to quickly remind about the three main server core capabilities. The first one being self-serve capability, which is the option for the user to perform data translations by themselves by selecting or downloading the data or uploading the data for validation. The second core capability is the real-time. It is the capability of Fme Server to connect to real-time sensors and live data feed and react in real time. So this is the capability we are most interested in creating our live spatial dashboards. And the third one being automation, which we have talked about earlier today. And it is the ability to run tasks at a specific schedule. And it is a great feature to continuously look for updates as well. So with these things in mind, I'd like to talk about how Fme Server can help in creating dashboards. So the first one being the real-time capability allows us to connect to live data feeds and process data live, which is very important for spatial dashboards. Yes, the second one is FME can connect to about 450 different formats and applications. So even if your BI tools does not support a particular data format, you should be able to convert it so that the BI tools can read it properly. So FME, data transformation and validation. Sometimes in BI tools, the input data can be in a rigid format. So with FME Server, we can automate the transformation of data to match the required format. Automations in FME Server will eliminate the manual checks and hence provide consistent data every time you run it. So finally, notifications and updates. So in real, FME Server can provide notifications and push updates in real time. So I'd like to talk about spatial dashboards. And so spatial dashboards provides live updates of spatial data. I'd like to demo a live spatial dashboard prepared by Safe Software. Just give me a minute and I'm going to switch my screen to this live spatial dashboard. So the screen, the dashboard that you're seeing right now is a live dashboard powered by FME Server. Here we can see the ships and planes routes in real time. So we can see they are moving as in real time. So in this demo, FME Server is pulling data from various sources and various formats. The ship data is in AIS format and is pulled from a live streaming feed, whereas the flight data is provided in a JSON format via web service. So FME Server takes them all and puts in a spatial dashboard like here. So this is one example of a spatial dashboard, but you can use various other data into your dashboard, such as any natural disasters, or bushfires, earthquakes, road condition, and it can be used to see if these disasters or anything affect your organization's assets. Similarly, FME can connect to real-time sensors and IoT, can connect to different message brokers as talked earlier. So FME can parse those data and process it in real time and create spatial dashboards. And finally, like alerts and notifications can be sent via FME server in this whole dashboard process, and that will make your whole process complete. So that was about spatial dashboards. I will be providing the link to the FME service dashboard in the chat. So we do have that available in the chat right now. So now moving on to business intelligence tools dashboarding. So there are various BI tools like Tableau, Click, Power BI, and others, which enables users to visually identify patterns in their data. So with this kind of dashboards, our goal with using FME Server is to prepare the data sets to get the most of our BI models. We are not trying to replace the BI tools, but we are trying to get the data when and how or where we need it. So in order to prepare the data sets, we can start with data cleanup, which can be done in FME Server. Like merging multiple data sets. So sometimes the data can be across multiple sources, and Fme Server can bring all those together into a single data set. The other one being filter data. So you can remove duplicates or total columns, which is important to be removed before passing into a BI model. Also, to consolidate columns. So the data will work better in BI tools if the columns are condensed into columns that represent key and value. Finally, like schema translations may be important to get your data into a particular BI format, such as renaming the column headers, changing the attribute types, removing duplicates or merged cells or nested tables. The other process that we can do in Fme and Fme Server to make BI tools dashboarding easier is and efficient is data enrichment. So Fme can calculate, perform calculations, build network relationships, and distance models. And also we can bring other data sources such as demographics and enrich our data. And finally, like Fme is known for its spatial analysis capabilities, and it might be powerful for then your BI tools for spatial analysis. So Fme and Fme Server can like connect to various GIS data, perform spatial joins, perform geocode addresses, which might be required for processing, like getting your insights from BI tools. Also, sometimes the data can be in different projections, and Fme can reproject the data into into a common projection, and so that the BI tools can overlay and give correct outputs from output from them. Also, we can create like density maps. So these are the some of the things that we can do to prepare our data sets so that our BI tools can get better results from them. So having said that, I'd like to talk about some of the connectors that we have available in Fme Server. So for Tableau, we have Tableau Data Extract Writer. For Click, we have Data Exchange Writer. For Power BI, we can connect to various data sources such as Excel or SQL Server or any other database. And also for ArcGIS, we have ArcGIS Online Connectors. So yeah, with these things in mind, I think the Fme and Fme Server can really help to make your dashboarding jobs easier and efficient. And yeah, that's it from me. If you have any questions, just I'll be around and let me know.
A question we've got here, can we build APIs with Fme Server without using AWS or Azure Resources?
Yeah, probably
Pri,
I'll
would you
ask.
like to answer
Yeah,
that?
I'll answer that because I talked about the APIs. Yeah, so yeah, actually that's a good question, because probably they might even ask this question because we talked about the serverless architecture. But actually we can use Fme Server or Fme Cloud itself without this intermediate third-party cloud application to build APIs. Because Fme Server and Fme Cloud both has REST API, their own REST APIs, and also we have a JavaScript API built as a wrap around this REST API. So it's quite easy to use those components to build APIs without using third-party applications. But again, to use them, you might need to have some web development skills. But using these cloud-based interfaces, it makes it simpler, and then you don't need to have really these web development skills. And Yeah, also using these cloud-based other interfaces, you can get better error handling and all sort of things, and documentation, because once you build API, another problem is creating documents. But with these the third-party application, they provide interfaces to build those API documentation quite easy. So I hope that answers the question. Yeah.
Thank you, Pri. Anyone wanted to add any more to that? No? Yep.
We've also played around with Kong. There's an open source API management layer called Kong. And I even think there's a knowledge base article on configuring FME server. You aware of that, Holly? So anyway, we can dig that up. Yeah.
Okay, thank you. Another question I've got here for Sam. If you need to wait for a batch of files from a directory watch trigger, what would you suggest for keeping track of what files have been received, given that each file will trigger its own process?
Yeah, okay. It's funny. It's a problem I run into. 'Cause the way I've like Holly and Don might correct me on this one. The way I've always thought about the automations is almost like a template that every time you trigger it, it kicks off a process using that template. And if I have 10 files or 20 files drop at the same time, it's going to instance a process for each one of those. And there's not going to be a huge amount of awareness on if those files are related to each other or not, because they're in their own standalone processes. So what you need to do, in my experience, is you need to basically cache your file list. For me, it's generally a Postgres database, something along the lines that I pretty much keep track of. And if I'm expecting a high level of concurrency, so I'm expecting to actually, let's say I've got 6 or 12 engines that I'm actually receiving mass files at the same time, I actually typically buffer out the execution of the downstream processes by a few seconds, just so that if you hit like if you're waiting for 85 files and you hit like the last 2 at the same time, you between when you write those files to the database and when you trigger the downstream process, you hit those 2 files, you can have excessive execution. So I actually buffer it out typically. I do a little bit finagling where I actually do a HTTP call to a schedule. So if you update a schedule and that schedule gets updated every time an additional file is received, it just pushes the schedule back. And eventually, once you've stopped receiving files, the schedule will finally execute. That's how I generally do it. I'm a big fan of using schedules. Basically dynamically creating schedules to either buffer things out or create delays that don't consume engines. That's the other way. The other reason I do it is that I do it to avoid decelerators.
Thank you, Sam. I've got a question here. Where are we? What advantage does Fme Server provide as compared to data prep tools by the BI tools? I think that one's for you, Assis.
Thanks, Andre. So with Fme Server, like I've talked, I think they can provide advantages over like various data types that Fme can connect to, and especially with spatial data sets, the BI tools may not be able to process spatial data, and preparing data through Fme Server can be helpful. Also, like Fme Server can have different types of triggers, which may not be available in the BI tools data prep as well. Yeah.
Okay. Thank you. Any other comments from the floor? No? Okay. Yep. All right. Another question has come through. I think I need extra Fme server processing power, and I think dynamic engines is the answer. What reporting tools or data should I look at to compare running with or without dynamic engines? Is it just processing time, or is there more? Holly.
You want to take that one, Don?
Sure, I'll take it. Yeah. So this is a great question, and something that at SAFE we've been looking at. It's like when is an engine busy enough that dynamic engines, or idle enough that when dynamic engines make sense. And so we've done a number of things in FME 2021. Again, now when you look at your jobs or your workspaces, you're going to see how long that job took on average, how much memory that job took, both in runtime and CPU time, and then you can get a percentage of CPU. So the dynamic engines, the cost of the dynamic engines is by CPU hour, and so you can look at the rate you're paying per CPU hour, and then you can look at the rate you're paying for a standard engine, and then you can then quickly do the math to determine, what is the price that makes sense, what is most economical for you there. Now with introductory pricing, because we don't even know, full disclosure, we don't even know if we got the pricing right. We've done lots of tests internally, but until we actually get it out there, we don't really know. So you'll see that it's not a warning, but it's dynamic engines, introductory pricing with a nice innocent looking box. And that just says, we just need more data to know if we get the pricing right. But the only way to get the pricing right is to come up with what you think is fair pricing, put it out there, and then see how it goes. But we think for many things, it makes a lot of sense. You could have an IoT stream, for example, where you have many periods of the day where there's not a lot of messages, but other periods during the day, they're very peaky. And so for data streaming, you need to dedicate an engine. So in some cases, a dynamic engine would be the way to go. So how's that did I even answer the question? I think I did.
I'm going to step in and kind of answer the question as well, because obviously you touched on 2021 and all of these metrics that we're adding, but right now it's not as straightforward to immediately spot in the interface how to kind of distinguish the CPU versus elapsed time, and that's a really important distinction to make when you're looking at dynamic engines, because a job could be running for an hour, but CPU time, it was only a few minutes. So at the moment, if you want to be finding that CPU time, you need to be looking in the actual job log, and those metrics are recorded in the bottom of the job log. So from 2021, they'll be really nicely, it will be easy to visualize those in the interface, pull them out of the REST API and things like that. But just at the moment, if you are looking on your FME server currently and your current jobs, you can find that information in the job logs.
Excellent. Thank you. Thanks, Holly. Thanks, Don. I'll do one more question. I'm conscious that we have really run over time, but I'm sure that people are very interested in the answers to these questions. A question from Michael Breen: how can we leverage the power of FME Server through our own custom UI? Thinking website forms, not emails or automated scheduling, as opposed to the standard FME Server UI?
Sure, yeah, we have FME Server Apps. I mean, we've seen organizations make nice web interfaces that look like their corporate web interfaces with FME Server Apps, and they can put the nice graphics. People within the organization don't even know it's FME Server underneath, and that kind of is the point for when people are using web applications. They don't really need to know what's going on underneath. So, yeah.
Okay. Well, thank you. I'll move it on. In conclusion, you've learned how to integrate FME Server with your existing or planned solutions. You've learned how to make the most of FME APIs. Dynamic engines will allow you to expand and contract your server setup as needed. There are a number of ways to dashboard with FME, and please contact us if you have any other questions or need more information, either at our sales.australia@onespatial.com or call us on 1300 290 686. Just very quickly giving you a plug for what we'll be doing next year and where you can find us. As you can see there, we will be at a number of events throughout the year, and we would welcome you to come and visit us at them. Just in conclusion, One Spatial Services, we sell, support, and provide training We are an FME Platinum partner. We are also a premium MSP for FME Cloud. We have a dedicated support team for One Spatial products, FME Desktop, Server, and Cloud. We have skilled FME certified staff globally with the ability to provide you with certified desktop and server, as well as accredited trainers. Our services are providing facilitated product evaluation, consultancy services, public and bespoke training services. As we all know, through this year and probably into a lot of next year, we have been running our training online. We have a comprehensive calendar on our website. I'd welcome you to go there to find out more. For technical support, you can go to support@onespatial.com or call us on 1300 290 686. In closing, I'd like to thank Don and Holly very much for your time this evening for you and this afternoon for us. Very much appreciated, and we look forward to catching up with you in the new year. From all of us at One Spatial, season's greetings, and we wish you all a very happy new year, and we look forward to, as it was this year, a very strange and different year, and next year, again, it will be different, and we look forward to seeing you in it. All the best, stay safe, and thank you very much again.